Well, thanks for the invitation to come. This is a topic that has been actually quite popular this year especially. We've just come to the end of our project itself, 4 years for the one that I'm going to be reporting on. And one of the reasons, well, I should explain why a range ecologist is looking at annual crops. The reason basically is we're dealing with plant communities. A range is looking at grassland communities, so annual crops kind of fit that nicely. So I'm going to try and cover in this talk is kind of providing you a setting, give you some definitions as to what cover crops are and what they could do for you, what needs to be considered. One of the things that we'll go into is functional groups, because we'll look at functional groups as to how you pick some of your plant species or your species. And we'll get you right into the Swift Current experience itself. We have a number of projects ongoing, and then we'll give you some examples of how you might want to select your species, and of course, some non-traditional options. After all, I deal with native plants, so I've got to throw some native plants into this presentation somehow. And then we do a summary quickly. So with that, well, this first slide basically is to give you the idea. When you're looking at these cover crops, you have to be looking at more than just the crop itself and producing something. You have to be aware of the climate that you're going to be growing in, because this will affect what you're going to be putting in the ground. That climate itself can result in disturbances. Like this last year, we've had a lot of fires. Well, it's been indicated that probably has a lot to do with that warming of our climate, that dryness. Well, especially this year, we had very dry. So we have a disturbance. With that disturbance, we wind up with invasive species. The potential for invasive species. So again, what you select will impact how those invasive species may or may not work. And with invasive species, well, they happen to like carbon dioxide, which, and then again, moves into that climate, because carbon dioxide has been implicated in changing our climate. So really what I'm trying to get at here is there's a number of things you have to be looking at. You can't look at one thing. You have to sort of look at the whole package and understand what you're trying to get at and pick the best. As I said, with annual crop cover, we're looking at a plant community. This particular picture is of a prairie situation, but what we're trying to get with the annual crops is that varying root depths, the different types of roots that will access the resources that are available to the plant and to the plant community itself, and that sort of maximize that, as well as building that underground environment. One of the things that tends to happen a lot is people focus on that above ground. And really with the cover crops, you're focusing on what's happening below ground. What you're going to get below ground that will help you with your future cropping itself. This particular slide, I'm not going to quiz you on what's actually there. The point of this slide really is to demonstrate that under different species, you actually have different microbial communities. And actually, these communities will change according as to when you take your samples during the season, as well as by depth. The key thing to remember is that every plant has its own community. So if you have a variety of plants out there, you're actually looking at a much more diverse microbial community. And that is quite important. We just published a couple papers out of Swift Current where we looked at different agricultural practices and going from a monoculture to a native prairie, and how those microbial communities. And one of the interesting things was they all have microbial communities, and they all are fairly dense. But the monocultures had a higher incidence of pathogens. In some ways, you can think of it as sort of those probiotics that you're being asked to take and improve your own digestion system so you function better. It's the same thing. You're loading up on the good stuff, and hopefully it eventually drowns out the bad stuff. So with a more diverse microbial, you should be able to take and sort of swing that balance to more positive microbial bodies. So what exactly are cover crops? One of the things that a lot of people tend to look on a cover crop is that production, the production aspect. What am I going to get? How much biomass am I going to produce? In reality, a cover crop is a primary purpose of improving or maintaining ecosystem quality. So it's a little different than just looking at production. you're actually looking at what you're going to get in the long run as opposed to the immediate benefit. So it's a little different way of looking at putting a crop together. And of course, there's a good list of reasons why people want to do the cover crops. We've already kind of indicated with the soil, we're increasing that biodiversity below the surface. We're also increasing that biodiversity above the surface, which has its benefits. You're also increasing the soil infiltration, leading to less flooding, etc. Reduced erosion. You're also retaining nutrients, hopefully. And you add nitrogen through fixation. And then you combat weeds, and you hopefully will be breaking disease cycles. Now with the literature basically supports this. The first one though is sort of more of an indication where we've come from. At one point, 1973, they were saying the most important living organism in the soil are the higher plants. I think we've moved away from that to say it's actually the system itself. You can't look at one entity. So you need to have both the microbes and the plant and the soil. It all works as a system, not one thing above the other. And we have a high confidence in the following. The appropriate species combination increases productivity and nutrient nutrition. Invasive, undesirable species are affected by plant community, as in the plant community is better able to take and ward off those invasive species. And diverse plant assemblies deal with diverse climatic impacts better, as in if you have a mixture of plants with some that are adapted to drought, some that are adapted to moist environments, that community can then move back and forth across those extremes, and you'll get some production. We also know that rotation benefits are driven by species rotation, as in how many species, and again, we're back to that microbial diversity, aiding that. And plant diversity impacts microbial community structure. As already said, again, that paper is actually from Swift Current as well. Plant diversity thus impacts nutrient mobilization such as phosphorus. Phosphorus is one of the things that shows up first. Most people surprise as opposed to nitrogen. It's the phosphorus. You actually get an increase in phosphorus. The interesting thing is, despite all these things that we've said about biodiversity being important, having a diverse crop mix or having a diverse number of crops available, a recent paper in 2015 actually identifies we're actually going in the opposite direction. They're actually seeing fewer species occurring in the United States, and I'm fairly sure that would be probably mirrored in Canada as well. But having said that, there is an increased interest in cover crops. In fact, they've provided a new name of recent. We call Regenerative Agriculture, and it comes across with the same definition. Basically, it's the ecosystem functions that you're looking at, not necessarily the production. And of course, there was an announcement to the south of the border with a fairly large research effort or funding available to take a look into it. And we also have the recognition that cover crops are essential to maintaining crop productivity in tillage when tillage is reduced. Very much like our minimum till or zero till operations up here. An appropriate selection of mixtures can stimulate subsequent productivity through return of biomass and nutrients to soil. So we actually could see that improvement in that environment. So we already know all this. So why are we even doing this work in Swift Current? Well, one of the reasons we're doing it is because most of these studies tend to be in higher moisture areas. Swift Current, we're in the semi-arid, as is much of southeastern Alberta as well. So we need, the question that was asked by the producers, and by the way, the reason we did this research was because it was driven by the producers themselves asking the questions. Can you provide us some answers specifically as to whether or not this is going to work, or is it all just hype that's floating around out there? So one of the things you have to look at is the number of species that you can use is almost infinite. So you got to break it down into what those species are actually providing you. So you start looking at functions. And this particular chart is available for those of you who are interested from the Mandan Research Center, USDA in North Dakota. And I use it because it provides that nice it gives you that sweep. You're looking at cool season. and versus warm seasons plants. Within that, you have your grasses and your broadleaves, and within the broadleaves, you have your legumes. So you have those different plants providing different functions. And of course, when you're planning this, you need to plan ahead. You have to be aware of what your goals are. Otherwise, you can wind up with a wreck, which everybody likes to avoid. They can be quite costly at times. I'm sure this individual really enjoyed pulling his tractor out of the field. So you need to be aware of your habitat, your soils, what type of moisture that you are historically would be available to you. And are you trying to correct low productivity, poor soil fertility, and exactly what are your production risks that you're looking at. And again, this map here is just to sort of emphasize, depending on where you're farming, you're working in an environment that has soils that are specifically developed under those environments, and as a result, you'll also have plants that are adapted to those specific regions. So when you're looking at things, like I said, there's an infinite number of species out there, and there's lots, and people will be promoting a variety of species that work for you, but you need to know what works in your area. So the Swift Current experience. At the moment, we just wrapped up the polyculture study, which is sort of the main emphasis of the data I'm about to show you. We also have a 12 species mix in a rotation, long-term rotation. That one thus far is, again, indicating that increase in phosphorus. We looked at species placement. It doesn't really matter if you're putting your large seeded with your small seeded all in the same row or separating them out. We found that it really didn't matter. And then we also look at, we have done some work, we're just starting to do some work with the role within organic systems, how they would, that play. And here, I put this one in. 2017 was is the driest year on record for Swift Current. Since April, we had a whole 8 millimeters of rain. Actually, I think we had 8 millimeters of rain right up into August. That's all we had all summer. And these plants, or these blends were actually seeded in June 19th, which is later. Again, we've been doing our research with our blends being, our polycultures being seeded later because they're supposed to come in after you've done all your high cost or high profit crops. And then sort of a fill or emergency feed. And what we see here is even though we had that minimal moisture, we're actually getting a fairly good stands. Okay, here's the polycultures crop itself. On the left side, you have some of the plots, and in the larger picture is actually our 12 species mix. Within the experimental design, we looked at 4 functional groups. We had our cool season grasses, which included barley, oats, and triticale. Excuse me. I suffer from asthma, so I get this tickle in my throat every once in a while, so I get to cough. And, it's just a thrill. Warm season grasses, which include your corn, sorghum, and millet. I will say right now the corn functioned well, but never got past the vegetative state. Legumes are nitrogen fixers, which were our forage pea, field pea, and hairy vetch. And our brassicas were the forage radish, turnip, and kale. These ones were brought in more as for their taproot characteristic. And so our treatments then become, we've got 34 treatments. We have monocultures, then we have that 2, 4, 8, and 12 species. We also had a perennial comparison just to see how the perennials will work up against, go against the annual crops. And you have to realize this experiment was not done in sort of an agricultural setting, as in you would use this in a rotation, because we had only 4 years of funding. We're trying to take and determine some of that soil parameter impacts. So we seeded the same treatment on each plot every year for 4 years straight. Something I do not recommend you do, but in order to get our results, that's what we did. And again, it was seeded early in June, harvested late in August, no inputs, and we also were looking at, again, one-on-one. The seeding was based on pure live seeds, so when we had, let's say, 2 species, you had 50 seeds of each. So you had the same representation, so you can compare what those species impacts might be. And here we're actually looking at that biomass production. This is 2013. We had the same trends that went through all the 4 years, except for the perennial. The perennials actually were outperforming the annuals by the 4th year. What we see here is that the species mixtures, the more species you had, the better the biomass production. Although the 12 species is pretty much the same as the 10 species, because we had 2 species in there that didn't perform at all. So we're really looking at 10 species. And our recommendation was sort of that 9 species looking at our blends. Our blend was probably the best. The other thing I should say, I haven't said, is that the species we picked, we didn't go exotic. We went with what was being grown in the area already. So what we've used is not necessarily what everybody else would use. The one cool season monoculture that worked really well was the barley. It competed as well as the mixes. Species compositions, like I said, our kale and our sorghum just didn't perform. They just failed to actually really produce anything. Quite often, by the end, we were getting 3 or 4 plants per plot. So the other benefits we observed were that they maintain cover, thus maintaining a functioning soil ecosystem, especially in those dry years when the soil starts to bake out. If you have nothing covering it, your microbial communities really do suffer. We also saw a decreased insect damage to the Brassicas. If we had monocultures of the Brassicas, the flea beetles just took them out. Whereas with the mixtures, the flea beetles had problems finding the Brassicas. And the key thing here is increasing the water-stable aggregates over a 4-year period. This is what we were going for. We were trying to determine whether or not we would have an effect on the soil organic matter. The water-stable aggregates is our way of assessing whether or not we had an increase in soil organic matter. And we actually were able to show an increase in that. So we actually got an increase in our soil organic matter, which means that this system has the ability to take and increase your organic matter, which is one of the key things that was being suggested that this would do. Having said that, organic matter is not the same as carbon sequestration. Further work would have to be done to take and determine actually for how much carbon we're actually sequestering. The feeling in the discussions I've been participating in are that we're probably the organic matter is probably the more labile or the carbon that doesn't necessarily stay around for years on end. It's very transient. Mentioned a bit about species selection, and I thought I would touch on this because there's a lot of species out there, and here I've just picked the legumes. Here's three legumes that are being recommended quite a bit. You know, on the surface, you think, yeah, they should work, but for the semi-arid region, especially, you start looking at them. Well, the first one has drought tolerance, but that bottom line says it naturally reseeds. So are we actually providing a weed into a system that you don't want? The crimson clover, well, it has a low temp tolerance, needs that fertile, loamy soil, slightly acidic. But again, it naturalizes, so there's something there to be watching, because it could become a weed as well. And the berseem clover, which provides weed control but doesn't seem to naturalize, provides that requires a high moisture content. So these are all three of these are being recommended for right across the prairies. So which one would you pick? Would you put them all 3 in, or none? And as I said, I work with natives, and from all these lists of all these species, what you'll find is they're all introduced species. So my question is, why haven't we looked at some of our natural or native species, such as slough grasses, which is your annual grasses? It could well maybe replace some of those introduced species. We have a number of legumes, such as American vetch or slender milk vetch, which would provide that legume component. And then for that taproot, well, we have that breadroot, which actually was a staple previously of the indigenous people. For potatoes, actually, it was there, or it's sometimes called the prairie turnip. It would provide that sort of tillage effect that the roots would. And I got this slide from a colleague of mine at Swift Current. This is just the first year of data he got. This is off monocultures. Brassicas are one of those species that is quite often suggested with these mixtures. One of the uses of the cover crops is to have it grazed off or take it as green feed. And the Brassicas also move into that, provide you that green grazing material into fall, potentially. What this slide does identify is a potential problem that you must be aware of if you're going to be using these species. First off, the Brassicas are nitrate concentrators. So when you have that freezing event, you could wind up with nitrate poisoning of your animals if you're not careful. They could overeat and give you a different table decoration. And the other one is the sulfur levels within the Brassicas. They're very similar to the canolas. There is the compound, which I am going to forget, and probably usually never get my tongue tied or wrapped around properly anyways, but it's a sulfur effect. So there again, you're going to have to provide minerals to take and sort of deal with the potential there of those. And really what the work we've done at Swift Current, what it really has identified is probably a need. And yes, people will say I'm a researcher, so I'm just making sure I have a job tomorrow. But that's not it, because at the moment, funding agencies are sort of a little shy on providing money. But these are the things I think need to be looked at. Really, how much residual do you need? Because the thing is, we took these crops off as green feed, so we removed 90% of the material. So that soil organic matter was based on the root material, not the above ground. How does the mixture impact the following crops? That really hasn't been looked at. Are there mixtures that maybe have greater benefit for certain crops that follow? Like, is there a better mixture that would probably benefit, let's say, brassicas, such as canola, or is there something that would maybe be a better benefit to, let's say, if you were going to follow it with the legume? And disease transfer. There's been a lot of discussion of disease transfer. Actually, there's been a lot of discussion of disease at this meeting. But nobody really knows with the cover crops. What are the risks involved with moving, let's say, legume diseases from one year to the next using your cover crop? One of the things that was I mentioned earlier was that the idea that these cover crops are supposed to break those disease cycles. Well, do they if you have the wrong species in there? And weeds. Are they a solution or means? As I indicated, some of the species that are being recommended could be weeds. Right now, a lot of the work, we've been holding field days. We're getting up to 200 people showing up at our low input field days. And one of the things that they're really interested in is the weed control. This is, we didn't apply any herbicides, and we're getting really good weed control on our more higher species mixes. So this might be an option for weed control. So, in summary, hopefully you're one of these people that will be holding on tight and enjoying the ride, not the other ones that are enjoying looking at what's on the other side of the raft. Know your environment. Understand the limitations of the site. What type of soils do you have? How that might impact, as well as your precipitation. We're in the semi-arid region where I work, so we know that we're going to be dealing at some point with low moisture. And we definitely had that last year. We'll see what we get this year. We are due for a multi-year drought. Select species that work for your environment and goals. Again, it's that word goals. You need to know what your goals are going to be. What exactly are you trying to take and do? If you're looking at production, maybe cover crops is not what you want. Or if you're going to be seeding the same thing, cover crop on the same field year after year, well, what our data would show would be that you should be going with the perennial then. Your perennials are better off. You're better off the perennial. You don't have that seeding every year. You don't have the seed costs every year. And your productivity is actually better off those perennials for multi-year. And understand what to contribute to your mix. Understand what those species, what you're going to contribute to your mixes. You don't want to sort of put them all on one side if you're looking for a benefit, a multiple benefit piece. Again, we look at that soil biodiversity. You're trying to get sort of maximize the environmental benefit, not necessarily the production benefit. So again, tailor your mixes to that. With that, I need to take and thank the people that have funded the research up until this point. We've had good support from our producers in obtaining some of that funding, such as Western Grains. We in the province of Saskatchewan has also provided, and then we have collaboration with university, and then our local Southwest Forest Association also helps provide some funding as well. And with that, I think I have 5 minutes for questions, if there are any questions.
All right, as we move to questions, so if you were concocting a perfect mix for Swift Current, would you throw in a mixture of range or native plants and a couple of others? What would your sort of good mix be, or would that be what you'd like to tinker with in the coming years of research?
Well, I think that's one area that we need to look at is to then look at some of our local natives to see how they would be adapted and how they could function. As far as the mix itself, you definitely need the legumes. What we need to determine is which legumes will work best and what percentage they need to be there. Because the one thing we're not picking up is that an increase in nitrogen in the soil with soil testing. Although we do get an effect when we take and break it, which is not what a lot of minimum till or zero till operations want to hear. But if we break it, we do get a release. So we know that with the nitrogen is probably being locked up within our microbial communities. So you need the nitrogen, and you definitely need the cool seasons. The warm seasons provide that, from a forage perspective, they will provide you that end of season, that sort of slump period when the heat's on and your cool season grasses are basically drying up. Your warm seasons you tend to be doing very well, so you want that in the mix as well. And then the deep rooting ones will provide, hopefully over time, that opportunity to bring micronutrients to depth up to the surface.
And anytime I've heard presentations on this, they always talk that it's a long-term view. And so in 4 years, have you maybe only scratched the surface of some of the benefits? Because really, is 4 years just a start in terms of the long-term view of this type of approach?
You're exactly right. This is just a scratching the surface. 4 years is much too short to really do this. This is, like I said, it needs to be included in your rotation. And rotations take several years. We have one that's still running at Swift Current that's 65 years, and they're still generating information out of 65 years with some very basic rotations. And we're just starting to include this in, and we're just, like I say, just starting to answer some of those questions, or actually ask some of the more pertinent questions.
Okay, any other questions at all? I don't see anybody jumping up. Okay, with that, we want to say thank you for opening our eyes and minds to this concept and providing some hard data of what's already been going on and the need for further work in this area. So with that, thank you very much, Dr. Michael Schellenberg.